Good morning, sir. My name is J. Charanteja. My roll number is 6633. I'm from CSC AML A section for second semester. Today my topic is string rotation. Introduction to string rotation. String rotation is a fundamental concept in computer science and programming, particularly in the context of string manipulation. It involves changing the order of characters in a string by rotating it, which can be useful in various applications such as cryptography, data comprehension, and pattern matching. In this presentation, we will explore the concepts of string rotation, how it can be implemented, its applications, and some examples to illustrate the idea. Understanding string rotation. String rotation refers to the process of moving characters in a string form one into another. For example, if we have a string A B C D E F and we perform a left rotation by two positions, the results would be C D A F A B. Conversely, a right rotation by two positions would be EFABCD. Types of rotations: left rotation and right rotation. Left rotation. In a left rotation, characters are moved from the front of the string to the back. For example, rotating hello left by 2 results in LHO, LLOHE. Right rotation. In a right rotation, characters are moved from the back of the string to the front. For example, rotating hello HELLO right by 2 results in LOHEL. Mathematical representation. If we denote a string S of length n, we and we want to rotate it by k position. For left rotation, the new string can be represented as A, B, and C. For right rotation, the new string can be replaced as BCA. Implementing string rotations. There are several ways to implement string rotations in programming. Below are two common methods used: slinging and using a loop. Method 1, using slinging, is a Python example. In Python, string slinging provides a straightforward way to perform rotation. Left rotation. For example, if a straight string is A B C D E F, then the left rotated string will be C D E F A B. And now the right rotation, and the string will be E F A B C D. These are two uh, left rotation and right rotation examples. Now method 2, using a loop. For languages that do not support slinging, you can use a loop to achieve the same result, but the code will be different for the different languages. but the output will be the same. Applications of string rotation. String rotations has several particular applications to computer science and programming. Cryptography. String rotation can be used in encryption algorithms to obfuscate data. By rotating strings, sensitive information can be transformed into a format that is not easily readable. Pattern matching. In algorithms like the Rabin-Krap algorithm, string rotation can help in effectively searching for patterns within large texts. By rotating subjects, you can generate all possible configurations of a string to check for matches. Data compression. String rotation can be part of data compression techniques, where the goal is to reduce the size of data by rearranging characters to find more efficient representations. Circular buffers. In systems programming, string rotation is used in circular buffers, where data is continuously written and read in a circular manner. This is common in applications like audio processing and network data handling. Game development. In game development, string rotation can be used for creating rotating text effects. Code comparison and time complexity. Time complexity for Slink method in Python is left rotation 0 to n and right rotation is 0 into n. Space complexity is also 0 into n for the new string created during the rotation. Loop method in C language. Time complexity of left rotation is 0 into n. Space complexity is also 0 into n for the temporary array temp used to store the rotated string. Reverse technique. Time complexity for the reverse string in left rotation is also 0 into n. Each reverse operation takes linear time. For space complexity, it is different. 0 into 1 if we consider the input string as mutable in languages like C or Python with lists. If we create a new list for the string, it would be 0 into n. Summary of comparison. Sling, slings, slinging time complexity is 0 into n. Loop time complexity is 0 into n and reverse technique is also 0 into n for the all languages, but Python or C in reverse technique the space complexity is 0 into n. Efficiency. All methods have the same time complexity of 0 into n, which is optimal for string rotation since we need to examine each character at least once. Space usage. The reverse technique is more space efficient, especially in languages that allow in place modification, as it can achieve the rotation with a constant space. Easy to implementation. The sling method is the most straightforward in Python, while the loop method is more common in lower level languages like C. The reverse technique, while sling slightly more complex, is efficient and elegant. In participant, the choice of the method may depend on the specific requirements of the application, such as the programming language being used the need for in place modifications, and the size of the string being manipulated. Conclusion: string rotation problems, comparison applications. String rotation problems. Understanding and solving using two main methods like left rotation and right rotation for a string. Comparison: iteration is simple but slow. Subtracting as fast as and efficient. Substringing is fast and efficient. Applications: used in encrypting, pattern matching, and more like game development. Thanks, sir. Thank you for listening me patiently. Thank you.